First question, give the most specific name possible for each shape. A few of you skipped this question. And notice the wording here. Give the most specific name possible. The reason why it's worded that way is we could call those quadrilaterals, and we're correct. They're four-sided shapes. That means they're quadrilaterals. Most specific name means the best name for what the attributes we see there are. So A is, Chase, kite. And B was trickier. What was B, Aubrey? So if you said parallelogram, you are correct. It is a parallelogram. But this tells us what? What does that little line tell us? Mia? Pardon? That they're the same length. Very good. So we have 4 equal sides. That's what it tells us. So yes, this is a parallelogram, but more importantly, it is a rhombus because it has 4 equal sides. That's what makes it a rhombus. 2A, which angle is closest to a right angle in this shape? Okay, we have problems with angles, so I'm going to call some people over. If you weren't sure, you could use something like this. I have 2 right angles right here and right here. I could line them up. If I'm not sure, I can look at that and say, well, that's not even close to a right angle. I could look at that one and line it up with that line and say, well, that's a little bit bigger than a right angle. That's a little bit bigger than a right angle. And if I line that up like that, it looks like it's exactly a right angle. So the correct answer is A. That's angle A right here. Okay? Which angle is closest to a half right angle? In other words, which of these is the smallest angle that you see? Maeve. D? Smallest? Okay, see when I do that, how big? Remember, the angle is this space in here. Is that space bigger or smaller than this space? It's bigger. So here is your smallest angle, angle C. Okay.
This is recording.
Yeah. Which angles are obtuse angles? So you don't have to know what an obtuse angle is until grade 5, but it doesn't hurt to learn it now. But I wrote this in case you weren't sure. An obtuse angle is any angle larger than a right angle. So the 2 are, again, here's my right angle. If I line it up and I can't see the other line, that's smaller than a right angle. This angle looks exactly like a right angle. And if I line this up with that, well, I can see that line. That's bigger. And if I line this one up here, I can see that that line is bigger. So my correct answers are B and D. Okay. Notice the plural here. Angles with an S, meaning there's more than one. Okay, name each 3D solid. This is called a, because that first shape you see there is an octagon with 8 sides. And this is called a pentagonal. If you say pentagonal, you don't have to use the word based. If you say pentagon based, you can do that as well. Pentagonal pyramid. Okay. Vertices, faces, and edges. So these diagrams make it pretty easy, but not totally easy to count. If we're doing vertices here, we've got 1, 2, 3, 4, 5, 6, 7, 8. And then we have to recognize that we're going to have the exact same thing at the bottom. So 8 plus 8 is 16. Faces. You're going to have 8 of these rectangular faces and 2 octagon faces. So how many faces do you have? And the edges.
24.
Okay. So if you recall when we learned this, we talked about the importance of understanding the role of the base. The base has 8 sides. This was 8 times 2, or 8 plus 8. This is 8 plus 2. And this is 8 times 3. Okay. That 8 sides plays a role there. The pyramid. Do pyramids have usually more vertices, faces, and edges, or fewer than prisms?
Yeah, fewer.
Fewer. Okay, so our numbers should be smaller here. How many vertices? 1, 2, 3, 4, 5, 6, right? We learned that every pyramid has the same number of faces as vertices. Do you remember that?
Yes.
Made a big deal about that. So, if you got one of these wrong and one of these right, remember, if it's a pyramid, faces and vertices will always be the same amount, same number. Okay? And then the edges, you've got 5 of these, right? And 5 of these. So how many in total? 10. I am a 3D solid with 4 faces and 4 vertices. What am I? Connor.
Triangular base pyramid.
Good. How did you find that out?
I just pictured it in my head of what it would look like.
Okay.
Hi, Aiden.
Yes, sir.
Can you put fences?
No, we're all done with them. Sorry, they're right here. Does anybody have one of those in their desk? Up top here, Aiden.
Wait, what?
Okay, so again, if you see this as the same, you know it's a pyramid. Then you got to think, well, my base, if you can remember that it's base plus 1, and so the base must have 3 sides, and a triangle has 3 sides.
Yeah.
If you can remember that, you're in good shape. Or you can mentally picture it in your head. Maeve.
I thought that the triangular pyramid is the smallest amount of and 4 is like the smallest.
Very good. So, when we're talking about prisms and pyramids, the only shape that has as few as 4 faces and 4 vertices is the triangular pyramid. It has the fewest number of faces and vertices. And that would also be true when you're talking prisms for the triangular prism as well. Can this net be for a pyramid? Explain. Yes or no?
No.
What's the problem with it? Aubrey?
It has a rectangle.
The rectangle should be a triangle, right? Any pyramid. Yeah, that was actually quite creative, Connor. I like that answer. I think what you're saying is if you like kind of folded this part here and this part here, it would work. Is that what you were saying? I understood when you explained it well, that I understood what you were saying. And you're right that nets often have like little flaps to help if you're actually building something. Those flaps are helpful. So I kind of saw what you're saying. That was good.
Unless it's blocks. Yeah, with blocks. Yeah, that would work.
So the rectangle should be a triangle. You should know that all nets for pyramids will have the base.
In the middle.
The base, it doesn't have to be in the middle, but the base and then the rest have to be triangles, right? We talked about this question when we did our skeletons with our straws and our clay. All prisms have exactly 3 straws coming out of the clay, right? Do you remember that? We had that discussion. But in pyramids, the bottom of the pyramid will also have 3 pieces of straw coming out of each piece of clay. But what happens at the top of the pyramid? Maeve? Okay, all of those straws coming up will come into that one piece of clay. So if you have like a hexagon-based pyramid, you're going to have 6 straws. If you have a pentagon-based pyramid, you're going to have 5 straws. In this case, you have 4 straws. So what must it be? A square-based pyramid. Yes. You're on TV. A quadrilateral has 2 pairs of equal sides, but on all sides are equal. List 3 shapes it could be. So, give me 3 shapes, 3 quadrilaterals that have 2 pairs of equal sides. Maya. A rectangle is a great answer. 2. Kiva. Yes, a kite will often have, will always have 2 pairs of equal sides. Something else. Cohen. A rhombus. A rhombus has all equal sides, but that's still true that both pairs are equal. So that is accurate. Maeve? A parallelogram is also true. And a 5th one could be square. Many of you wrote trapezoid, which I had a problem with because the only way a trapezoid is correct is if we go with the idea that rectangles, rhombuses, squares, and parallelograms can also be considered trapezoids, because our definition of a trapezoid is that it has at least 1 pair of parallel sides. But if we're saying trapezoid, there's a better name for any of those shapes, because if we draw a trapezoid that looks like this, okay, this side and this side are equal, but the other 2 are not. And if we draw a trapezoid that looks like this, then we may not have any pairs of equal sides at all. Okay? So a true trapezoid is not correct. A trapezoid that is also a rectangle, also a rhombus, also a square, also a parallelogram is correct. Okay. Name 2 3D figures that have 12 edges. Most of you wrote the same 2, which is fine, even though they're almost the same thing. Maeve? Yes. Right. Most people said cube and rectangular prism. Nothing wrong with that. There is a 3rd. Does anybody, and I think somebody got it, does anybody have the 3rd? A trapezoidal prism. You could have a trapezoidal prism. Could you build one? Could you build one? I think you could. But what else? There's one pyramid that works. What pyramid? Shh, we're listening. Megan. That's right, a hexagonal pyramid. Think about 6 sides to a hexagon, so double those edges. 6 plus 6 gives you 12 edges. Name 2 3D figures that have more than 4 rectangular faces. This is pretty easy, guys. Maeve, go ahead. Okay, I'm going to write this down. You tell me if I'm right. Every prism, except for one. Which one doesn't have more than 4 rectangular faces? Ava? Right. So that means a rectangular prism, a cube, a pentagonal prism, a hexagonal prism, a octagonal prism. All of those types of prisms work, right? Okay. Are all parallelograms also rectangles? Explain. So we're getting better at this, but we're not quite there. You have to don't focus on the parallelogram. Focus on the rectangle. What do you need to be a rectangle? And do all parallelograms have that? What do you need to be a rectangle? Ava.
You need to have right angles.
That's correct. So the answer, do all parallelograms have right angles?
No.
No. So, no. Parallelograms don't need to have right angles, but rectangles do. Okay? If you want, you could draw a picture like this. This is my parallelogram. And it doesn't have right angles like this, so it's not a rectangle. Are all rectangles also parallelograms? Yes or no? Again, don't think about what you need to be a rectangle. You got to think about what you need to be a parallelogram. What do you need to be a parallelogram? Aubrey? Okay, so 2 pairs of parallel sides and equal sides. Does a rectangle have that? Do all rectangles have 2 pairs of parallel sides and 2 pairs of equal sides? Okay, so what's the answer then?
No.
If all rectangles have 2 pairs of parallel sides and equal sides, and a parallelogram must have 2 pairs of parallel sides and equal sides to be considered a parallelogram, then what's the answer? Yes. Okay. A parallelogram must have 2 pairs of parallel sides, and a rectangle always does. That's how you'd answer that. Okay, for each angle, take a look at this angle. I'm going to use my thing again. So I'm going to put this corner right in here, right in there. Okay, nice and square. So what kind of angle is that? What kind of angle is this on my paper? Mia? Right, and it's just a tiny bit smaller, right? So A, if I use this angle again, it's larger than a half. See how it's larger? Okay, I got all this space in here that makes it larger. Okay, if I use my right angle and line it up, I can't see that line anymore. So it's a little bit smaller than a right angle. So what letter do I write? B. It doesn't say halfway between. It says between. It's between a half right angle and a right angle. Okay? Here we got a really big one, right? If I actually use this is like the big angle. If I use a straight line, it's close to a straight line. So what do I write? What letter should I write for this? Sadie? Is this angle close to a right angle or closer to a straight line? Good, so it's D. And here, a little bit bigger than a right angle, but not very much. I've got this space, extra space in here, so that is C. Okay? All right. So, if you did well on this, Review what you got wrong. Review it over again the next couple nights. Bring it home tonight. What did we write in our agenda this morning? So what is your geometry practice test? So what do you need to do with it?
And review it.
Right, you need to bring it home. Put it in your agenda.